Today we're doing a test cut on a Dow Styrofoam CladMate CM20 insulation. I have a potential customer who has an application for this material, and he needs to cut both sides of this material down to get the material to a specific thickness. In this case, well, the styrofoam is an extruded polystyrene, not the usual expanded beta stuff you're probably used to seeing. Good insulation material, actually. Relatively dense, it cuts easily, does make a lot of dust. But the current thickness of this workpiece is 3.5 inches. They want to trim it down to 2.86 inches total thickness. So we're taking a bit more than 1/4 inch off each side, which is a very slender cut. You also have to account for blade kerf, that is the material thickness of the blade, how much material it takes out. That's about 1/16 of an inch. So we're taking out something in the range of 3/16 of an inch. They do want to cut both sides of this. They want the same surface on both sides. So we want to take about 3/16 of an inch off top and bottom. This is a little difficult. The problem you get into is when you have a bandsaw blade, well, the easy case is that we cut right in the middle. When you're cutting right down the middle, the bandsaw blade effectively sees equal force from both sides. The material, if it tries to pinch in on the blade or opens up on the blade, does so evenly. When you're cutting a little teeny tiny sliver of material here off one side, and you've probably seen this if you've ever done any wood cutting, this top piece of material, I can almost guarantee you, is going to try to peel up away from the cut. The bandsaw blade is going to feel unequal forces. The bottom side here is not going to move at all. It's still going to be brushing against the blade. The top side, however, as it peels away, will not be applying much, if any, force to the blade. So the blade sees some force from the bottom, little force from the top. It's going to rise in the direction where it feels less force. So it's going to try to rise up out of the cut. You see this cutting wood, lots of other materials. The only time you don't see this is when we're cutting very rigid materials. Sometimes metal, materials like carbide, graphite that are very stiff, it may not try to pull away, but here, when we cut this, it's going to try to pull up. So one way to counteract this is to use a giant blade. We've got a pretty good sized blade on here today. I'm using a Forest Manufacturing Model 480P horizontal blade bandsaw with a traveling table. The blade I'm using today is a 1 inch wide by 0.035 inch thick, 3/2 per inch blade, so it's a pretty big, fat, and aggressive blade. We are cutting through 48 inch wide material here, so we're going to produce a lot of dust. These spaces between the teeth are what clear out that dust. We're also going to be running dust collection system, but a lot of material is going to stick to the cut surface anyway. That's just the way it is in these applications. So this will be a little tedious. I'm going to make the first cut. The material will cut pretty quickly. I'll make the first cut off the top, flip the workpiece over. I will reset my blade height to 2.86 inches above table surface. That's going to be a manual process here. These machines usually come with electronic digital readout for the blade height above table surface. We haven't set this machine up, calibrated up, so I don't have that. I'm just going to use a set of calipers to set that height. So first cut, assuming it goes well, will be to take about 3/16 off the top, flip it over, measure blade height to table surface. We should then be cutting off another 3/16 of an inch, make a follow-up cut, go home and have a drink. If it doesn't go well, maybe I'll try again, maybe I'll go home and have that drink anyway. Dust collection, please. Go ahead and kill the dust for now. That actually went pretty well. I'm sure I could have gone faster than that. But here's the top sheet I produced. Just for the sake of knowing. That's a 0.2. That's exactly a 1/4 of an inch. Yeah. Oh, actually, no. Yeah, 0.250 inches. So that's exactly a 1/4 inch material we just removed. So I'll set that aside. Play intermission music. We should be able to run it back without hitting anything. Okay, we got all the dust in the world here. Let's do this. Let's put it on the ground. Would you grab that broom again? We're gonna knock some of the excess dust on this. It produced.
Worked pretty good.
Yeah, nice cut.
Actually, that's pretty good cut. I thought it was a crappy cut, so all the stuff came off. I was like, what?
Yeah, that's pretty nice looking. A little bit of furring. Okay, that's good. Would you grab that in, please?
Sure.
Set it back on here. Okay, that's good. Now I'm going to reset the blade height. Get the table under it here. Set my calipers to 2 point, uh-oh. They're all out of whack. .8. 6 inches. There we go. So actually now, since we're cutting this so close, the bandsaw blade has a thickness and the teeth are offset to center left and right. So what I'm gonna do here, by way of just trying to get the best possible cut, try to measure to the bottom of the lowest tooth. That should do it. Obviously this is a little slow for a production environment, but this is just to prove we can do it. Once we've proven we can do it, then we figure out how fast we can do it. But nobody cares how fast we can do it if we can't do a good job of it. Okay, I think we're ready for the second cut. Dust, please. dust in the world. Let's put the calipers on it real quick, see if we got a result. .90, so I could have moved it down a little bit more. So 2.90 inches. Let's check the corners though. Let's see if we got consistent. .30. .86. .8, 40. .92. .890. .820. So we'll need to even out the table a little bit. So this will actually be an application for a precision table, but I think we can get there.